Early analysis of system integration. This topic will cover a prerequisite and a requisite for the LEED 4.0 certification as a part of the integrated process category. First of all, what is a prerequisite? According to the LEED certification, a prerequisite is the minimum requirement that all buildings need to meet to achieve any LEED certification. The first prerequisite is integrated project planning and design. As the name says it, this prerequisite refers to planning who will be the people involved and designing what will be done. This part of the prerequisite must be preferably done before the schematic design of the building is completed, since change may be done. It is also important to mention that this prerequisite only applies to healthcare projects. The first step of this prerequisite is to identify the different team members that will be involved in the project, where at least a minimum of 4 different professionals must be within the team, in addition to the owner or an owner representative. A professional may be an architect, a structural engineer, green building consultant, among many others. Once the team is assembled, they should all meet as soon as possible with the owner to determine the preliminary project goals, such as which LEED certification level will be sought and which LEED credits will be complied to satisfy the points needed for that certification level. Next step will be for the owner to develop an OPR or Owner's Project Requirement, which is a written document where he describes the ideas, concepts, and criteria that should be considered to be important to the success of the project. Once the OPR is completed, team members should hold a design charrette, which is an intensive workshop where all the stakeholders can collaborate to explore design options. This meeting should be at least 4 hours long to discuss the different strategies and how to approach them to meet the adequate completion of the LEED credits. This charrette will also be helpful to align the project team around the owner goals for the project, like budget, schedule, functional requirements, scope, quality, among others. The team can also use the opportunity to establish each of the member responsibilities in order to satisfy the different credits. Some of the prerequisites and credits have a reference standard associated to them. These documents help the team comply with the credit, guidance, and strategies. The reference standard for this prerequisite is the ANSI Consensus National Standard Guide 2.0 for design and construction of sustainable building and communities.
Now let's continue to the integrative process credit. This is a new credit where it is required to identify and use opportunities to achieve a more efficient way to utilize energy-related and water-related systems. This will be achieved by doing an analysis regarding the loads of energy and water systems within the building to figure out a way to reduce them to make the building more sustainable. It is encouraged to do this analysis as early as possible to gain major benefit. The integrative process is split in 2 basic phases, discovery and implementation. Discovery is considered the most important part of the integrative process because it can be also defined as a pre-design phase where all the research for solutions takes place. Project environmental goals can be achieved cost-effectively if this phase is done correctly. For the evaluation to be within the goals of the owner, the team should meet for a goal-setting workshop, the same way as the charrette was made in the prerequisite explanation. This will help the team to align around in terms of budget, schedule, scope, functionality, quality, and occupants' expectation. During this meeting, water system goals and initial analysis will also be discussed, but that process will be explained after finishing with the energy system. The first component to evaluate within the energy system is the site conditions, where we take into account things as exterior lighting, such as where the sun comes out in the morning and where it goes down at night. Also, possible shades that may be generated from different elements in the surroundings. The second component to take into account is the mass and orientation of the buildings, meaning, is it better for the building to be 1 or 2 stories? How will the energy loads decrease or increase depending on this factor? Regarding the orientation of the building, What will happen if I rotate the building 90 degrees or 180 degrees? How the energy loads change? Basic envelope attributes refers to the insulation value of walls and roof of the building. In this component, we also need to take into account the windows to wall ratios and where these windows will be located. It is important to consider both things at the same time, since we want to control how much exterior heat enters the building in order to reduce the amount of energy required from HVAC systems. But at the same time, we want to have enough daylight to come in to reduce the amount of non-natural light needed by the building. The approach we will use either to have more daylight from windows or more insulation walls and roofs depends on the location and type of building we will be building, since these factors determine how much external or internal energy load will be in the building. The next concept is lighting levels, which seek to reduce the number of bulbs within the building by implementing a higher reflectance level. This is done by choosing different colors as paint for the walls. By doing so, the light of a bulb will reach a greater distance within the room, therefore reducing the number of bulbs needed to light the room. The last three concepts to be analyzed in the simple box analysis are Prereq and simple. These are thermal comfort ranges, plug and process load needs, and programmatic and operational parameters. For thermal comfort ranges, it is simply to research and analyze what are the adequate temperatures for people to not be too cold or too hot. Plug and process load needs refers to analyzing different equipment and their energy loads to determine which is the best option regarding energy efficiency. Lastly, programmatic and operational parameters refers to analyzing the building and finding a way in where its operational hours are reduced, in order to reduce the amount of energy to keep it functioning. It also refers if there is a way in where the building area may be reduced. Once the discovery phase is done, the project should move on to the implementation step, which is to document all the analysis done during the discovery process. Of the 7 components previously described, at least 2 strategies addressing these components should be developed in order to comply with the LEED requirement. This analysis should be described in the owner's project requirements, basis of design documents, and construction documents. The documents should show how the energy loads will be decreased by the reduction of lights and HVAC systems, together with the location of windows and the insulation and reflectance levels that will be used. Lastly, a worksheet provided by USGBC regarding the integrated process should be filled, giving explanations about the energy evaluation and energy analysis.
Now, let's move to water-related systems. The procedure to properly analyze this concept will follow the same methodology of discover, goal workshop, evaluation, and implementation as the energy systems did. For the discovery phase, projects should calculate an estimate for water usage for the building. This is also known as a water budget. This water budget is a project-specific method to calculate water demand for a specific amount of time, could be a week, month, or year, and a quantity such as kilogallons or liters. This water budget will consider the following 4 concepts. First, indoor water demand, which is an estimate of the water used for flow and flush, for example restrooms, in accordance with the fixture design methodology for water efficiency prerequisite indoor water use reduction. Outdoor water demand, which refers for all landscape irrigation, also calculated to the WE outdoor water reduction methodology. Then, process water demand, which refers to kitchen, laundry, cooling tower, among all these other equipment that can demand water usage depending on the type of the building. These are calculated by the WE credit cooling tower use. And the most important, supply sources, which are all the potential non-potable water supplies like rainwater, grey water, HVAC condensate water. All these sources are the ones that will try to reduce the potable water consumption from a building. In addition to the water budget, the project should gather data related to the water systems that are specific for the site where the project is located, such as location, capacity, and type of water treatment facility that will be serving the building. Also, location, capacity, and type of water sources serving on the site, such as lakes, wells, aquifers, or municipal supplies. Also, monthly and annual rainfall data, average cost of potable water, and potential financial incentives. All these preliminary analyses work as a tool to explore different ways to reduce possible water loads in order to accomplish sustainability. Now it is time to evaluate these options with the goals proposed on the goal-setting workshop, as it was explained in the energy systems part. Once the goals are set, the next step is the evaluation process. The aspects to consider are the following: baseline case water consumption, which is a calculated projection of the building water use, assuming that all fixtures and fittings comply with the code and there are no additional savings. Also, design case water consumption, which is a projection of water use based on the proposed size of the building. It is important to mention that both concepts should be applied to both indoor and outdoor demands. Once this is completed, the project should gather data, in addition to the one at the discover part, to try to quantify with more accuracy the possible potential non-potable water resources, such as captured rainwater, gray water from flow fixtures, and condensate produced by initially assumed HVAC cooling equipment. It is important to say that one of these alternate water resources should be chosen by the project in order to get the credit. The last step in this credit will be the implementation process, where the non-potable water resources chosen will be stated and developed. Also, it should include documentation about how these water resources analysis contributed to the owner's project requirements and the basis of design, or BOD, which is the information necessary to accomplish the owner's project requirements, including system descriptions, indoor environmental quality criteria, design assumptions, references, standards, regulations, etc.
In conclusion, this credit main goal is to research how to reduce the energy and water-related system loads and to analyze different strategies where these reductions may be applied. Also, completion of this credit is a great starting point to have an idea of how to adequately comply with different LEED credits within the different categories of sustainable sites, location and transportation, water efficiency, energy and atmosphere, and indoor environmental quality.